Welcome, everyone. I want to say thank you all for being here. I want to thank R4DS for just having the opportunity to have this book club. I want to thank all you for coming. Today, we're going to be going through another chapter of the data visualization with R book that we've been going through for the past couple of weeks. I'm Ken Vu. I'm going to be presenting that chapter for today. And start off, I'm going to load up a presentation that I've made. So that way you can all follow along with this. So let me see if I can screen share. All right. So let me pull this out of the way. And so for this chapter 5 of multivariate graphs in the book, we're going to cover a couple of things related to this chapter. As through this presentation, you're going to learn the following things. You're going to learn how to incorporate multiple variables into data visualizations beyond the X and Y axes by grouping them together. We're also going to look into some of the ggplot's array of customization in the context of grouping and facet wrapping, two brand new concepts that we're going to be learning as we go through this chapter. And then lastly, we're going to talk about facet wrapping and facet grids to create all kinds of different graphs based on the values of different variables as a way to show you that you can plot multiple variables on one plot beyond the X and Y or one variable, two variable that we've learned in chapter 3 and 4 of the data visualization with R book. That said, let's go into this chapter. So in previous chapters, you definitely learned a lot about how to plot one or two variables on a single graph. So examples of different kinds of plots that you may have worked with were histograms, where maybe you're looking at one variable and you want to see perhaps the proportion of points in a data set that identify with this category or that category. Or maybe two variables where you have an X and a Y, and you're plotting a scatter plot where you're looking, say, given the value for, say, this X, what's the value for Y? So plots like that really show what ggplot is capable of in terms of plotting one variable or two variable. So to start us off, before we get into discussing multivariate graphs, let's do a little example code where we're going to look into, say, a two-dimensional plot using ggplot. So what you want to do is generally what you can start, how we start off is we go to our RStudio. We load the packages, ggplot2 and dplyr, or if you want to, you can just do library and then tidyverse, which will load ggplot2 and dplyr. I just have it separate just out of convenience. That way I'm not loading the whole package, but that's another thing you can do. And then you want to load the data set salaries here from the package car data. And then with ggplot, in terms of setting up an example plot, you want to list the data set you're pulling from, which is salaries. And then AES, as you may have learned from previous chapters, is this function that allows you to set the X and Y for what's get plotted on the graph. So here we're plotting on the X axis the year since PhD, which is basically for this data set, we're looking at teacher salaries, and year since PhD basically is a variable that tells you how many years has it been since that teacher got their PhD. And then on the y-axis, you have salary, basically how much money do they make per year. And so this function here sets up basically which data set you're getting data from and what variables that you want to plot. So once you set that up, you have this geom point where you basically tell ggplot, I want a scatter plot. I want to put these two variables and plot them on a scatter plot. And then when you graph it, well, it takes a while to load. You can see here that you have this scatter plot. something that you may have seen before in previous chapters, where on the x-axis, you have year since PhD, and then on the y-axis, you have salary. And then you have this nice little scatter plot right here. So that's just an example of something you may have learned in previous chapters, just how to plot two variables on a single graph. And one way to do that is through a scatter plot. And while this is something that you may be familiar with, there's always that question of, what if you want to visualize more than two variables? Because you have two variables, but what if you want to get more information out of this data set? Because if you take a look at the salaries data set, or maybe just take a peek at it in R, you notice that there are multiple columns in this data set. As it's not just the year since the PhD or the salary, you also have variables such as the sex of the professor, male, female. And you also have years of service, how long that they've been an instructor, professor, and discipline, which I'm not too sure what that is, but I'm assuming it's some kind of categorical variable that has to do with, say, the nature of the work they're doing. I'm not too sure, but you can tell it's a categorical variable where the values are only just labels or names. And then you also have the rank, basically what kind of professor they are. Are they assistant professor, associate professor, or are they a full professor? So you can see here that there are multiple variables here in this data set. And one of the things, a data scientist might be curious about is, what if we can plot more than two variables? And thankfully, ggplot has a lot of tools and these arguments that you can include that allows you to plot more other variables in this plot and be able to get all kinds of information presented on the graph. So to start off, let's introduce a concept called grouping. So grouping as a concept basically means that you're getting multiple variables together and you're putting them on a single graph, and where you can change a lot of different attributes of data points to be based on values of other variables. And an example of grouping is something I'm going to show you down here, where there's some examples of things you can change are the color, the size, the shape of the points. And you can do all of this within the AES function in the mapping argument in ggplot functions. So if you go back to code, this AES function is where you can modify the points even further than just controlling what gets plotted on the x-axis or the y-axis. So grouping, to demonstrate grouping, one of the things that we can modify as an example, let's start with something simple. Let's say for this scatter plot here, let's say you want to know which professor. Okay. Oh, thank you. Yeah, thank you, Femi. Okay. Yeah, so so what Femi just put down was just a description of the variable discipline, which is a factor with levels A and B. So A being that the professor's from a theoretical department, and then B is from an applied department. Thank you. It's good. But anyway, so you see you have the scatter plot, and one of the ways in which we could add more variables is, let's say, for example, we want to change the color of the points to reflect which professors are assistant professors, which professors are associates, and which professors are just full-time professors. So one way you can do grouping is by changing the color of the points. So to do that, you just take your same code that you did from, say, the previous example that we showed, right? This code right here, which is basically a scatter plot with just two variables. And what you can do in the AES function is to modify it. So in here, you have your X and your Y, and then you can use the color argument, where what color does is that it changes the colors of the points based on the values of the variable that you're going to specify. So in this case, we're going to change the count of the points based on the rank of the professor. So you want to know, which professors are assistant or associate or just full-time professors. So, and when you run this, after you make this color argument, you can see here that you get that same scatter plot from the previous example, but this time we added some modifications where now you can see the color of the points are different based on the rank of the professor. So these red points here correspond to those that are assistant professors. These green points right here are points that go with those that are associate professors. And then finally, these blue points are for those that are professors. So that's just one example of many ways in which you could modify on the plots, so that way you can add more information from other variables. So that's an example of grouping, where you're taking these group of points, and then you're essentially adding more information where each set of values are have extra information based on the values they're assigned. So in this case, you have the paired data where years since PhD and salary, and then you add in an extra information based on value of another variable. In this case, the rank of the professor. So that's just one example for sure, and really shows you just how advanced ggplot is in terms of being able to plot multiple variables on top of the existing one or two variables that you have on this plot. All right. And before I might move on, I just want to ask if anyone had any questions or any comments or so on before I move on.
None for me, but awesome presentation so far. Thanks, Ken.
Okay, thank you. Yeah, just want to check in and be sure. But yeah, this is pretty much more of a extension, so I think it's very cool and very intuitive. So that said, so here you saw that you can modify the graphs based on the color. Now, that's not the only thing that you can modify. You can also modify other things as well. In addition to the color, you can also modify the size, or actually or even the shape of the points. So here's another example of a plot where we not only change the color of the points, we also change the shape of the points, where instead of the usual circles that you see in, say, a scatter plot like up here, you also have points where you can change the shape. So in this case of this plot right here, we're changing the shape of the points, where we have triangles here to indicate that the professor is a male, and then circles to indicate that those points are for a professor that's a female. And there's a way to do that. And the way to do that is just like something that we've done before, where all you do is you just go into this AES function within your ggplot function, and then you add an extra argument to tell ggplot to change the shape of the points based on the sex of the professor. So you take that same code that you just did earlier, as if I take this out, it's essentially the same code from the previous example, except now what we're going to do, we're going to change the size, or actually no, the shape of the points to reflect the sex of the professor, right? So that's just one little extra argument that we're adding here. And when you run this, here you could see that you get that same scatter plot as before, but now you've changed the shape of the points based on the sex of the professor. So you still have your rank and your salary and years since PhD, but you can see here, I know it's kind of hard to see here, but you kind of see that there's some triangles here, which mark that those points are for male. And then I think there's a couple of circles right here that indicate that those points are for a male professor. So that's pretty much another example of just how far you can go with customization, where you can see here, we now have displayed values for 4 variables. salary, year since PhD, the rank, which corresponds to the color of the points, and then finally, the sex of the professor in terms of the shapes of the points. So, great. Does that make sense? Now, while it looks really cool just to see how much you can customize with ggplot and just how many variables you can plot, one little note that I would like to make, though, is that we have to be careful about just how much you customize with ggplot, because while it's cool that we plotted 4 different variables, one of the problems that I do kind of see with this plot is that it's just too much information on this graph, and which might be overwhelming for the average person who might be looking at your graphs. As while it's cool to do all these things, we also have to sometimes take a step back and ask if this is something that is easy to follow along, because you not only have these 2 variables, you also have the colors of the points changing and the shape of the points changing. And you see here, this graph looks pretty busy, as you have some triangles here that are kind of mixed in with these circles and color. There's just sometimes too much to be focused on in this one graph. So while it's not to say that there's no value in doing these things, but it's something to kind of keep in mind, with any future visualization that you do. Not just what you can do with it, but also, does it make sense for the data that you're working with? And is this something that is not too overwhelming for the person that might be looking at your graphs? So that's just a little note you have. But other than that, you can see how the color and the shape of the points are just some of the many ways in which you can modify ggplot to be able to add extra information from other variables. And another thing that you can also do, besides modifying the color or even the shape of the points, you also change the size of the points, where points can get bigger or smaller based on that different values of certain points. So going back to RStudio, we're going to show some examples where you can demonstrate basically how to change the size of the points. So going back to the salaries data set. One argument we can incorporate is the years of service. Basically, how many years has that professor been working? And we can use that as sort of a variable where we can get the points on this graph to change based on just how many years of service. So what you do here is just kind of the same thing as we did before. Just go back to your ggplot function and go into your AES function, which controls how the plot looks, and add an extra argument where you can change the size of the points equal to years of service. So that's just another thing you can add. So once you do that, you just set size equals to the variable that you want. So in this case, years of service. And after that, once you plot it, you can see here that you can see how these points definitely do change size based on the years of service. So it's mostly the same plot that we've had before, except now we change the size of the points based on the years of service. So that's just another thing you can also customize, the size of the points. However, as you can see here, we do have a problem in that some of these points kind of overlap where you can't tell their points, because like you might have one point be on top of the other and you might not know there are 2 points actually there. And so that might be an issue if you're trying to present this plot to someone else who might have a hard time telling which point is which point is that. And so that brings up another thing you can also customize too. And that is, one way to address this issue is to change the transparency of the points. And one way to do that is to go into a function like geonPoint or something like that. So in case geonPoint, and then go to this argument called alpha, which sets how transparent the points are. Like how much can you see through the points? And you can set it to some number, with 1 being that you can fully see the point, like it's a solid color, and then 0 meaning that it's invisible. So we're gonna just set it to alpha equals 0.6, just as a basic, where it's not too transparent and it's also not too solid. And so when you run this, you can see it looks a lot better, right? You can see here that, that even though there's some overlap, you can still kind of make out the outlines of the points. So you can kind of tell where each point is. So you can see here how there's some, you can see here, and it's also good though, in that it can tell how much something is overlapping, where you can see how with these points overlapping that it's dark, which indicates that there's a lot of overlap, meaning that there are points that have very similar values that are very close to each other. And then you can see here that there are points here that are very transparent, which tells you that there aren't any points at all that are overlapping. So that's another tool that you could do, where you can just change the transparency of the points and fix it at certain value. So in this case, it's 0.6. Right? So that's just another example. So you can modify the color, size, the shape, or even the transparency of the points. And that's just other things that you can do with ggplot. And before I move on, any questions? Everything good? Okay.
Looks good.
Okay. So far we just kind of been talking about customization, just giving you a little demonstration of just the many ways you can customize your graphs and just add more information for other variables. And moving
actually,
on.
now that I think about it.
Yeah.
Oh, yeah. Now that I think about it, yeah, back to the other graph, like what you were saying, where it's too busy. It's also like where we had the shape and the color.
Yeah.
Beyond it being like busy, also it's kind of like when you added the shape, did you actually add value for your viewer? Because like you can't really even see, like the points are small, so you can't even really see and be able to differentiate like the circles from the triangles.
Mhm.
And honestly, because like there's no the transparency, like potentially maybe like a circle might be like covering a triangle or vice versa. So yeah, it's definitely very cool. Like I like where we added like the size, including the size, and then also adding the transparency. Those are very, very cool ways to customize our graphs.
No, definitely. Like I definitely kind of see your point though. Absolutely though. Like it's not just a question of just how busy it is. Also, does it make sense? And is it helpful? Where taking it out makes it changes the impact of that graph. Yeah. On the audience. But yeah, to that point, we're going to eventually, as we move through this chapter, we will talk about how to address that point where what if you don't want your graph to be too busy? And that's something that I will talk about later, but you'll definitely see it when it comes up. So yeah, I appreciate that point. Sure. By the way, Lydia. Anyway, moving on, I'm going to show another example of just grouping through some regression lines. So basically these equations of lines that are fitted onto your data points. And one of the cool things about grouping is that it affects other ggplot layers that you apply on top of the base ggplot function. So as an example, let's start plotting some regression lines and put them into the graph. So I know it's a lot of code, but I will walk you through it. So that way you have a sense of what's going on. So to start off, we'll have our basic ggplot function here, where you have your salaries, which is the data set that we're working with. And then the AES function, which is X is year since PhD, and then Y is just the salary. And then here, we're going to change the cut of the points based on the sex of the professor. And then we're going to do G on point, basically telling ggplot that we want a scatter plot with these points. And then we're going to have our alpha be 0.4, where we're going to have it to be a little transparent because we expect that there's going to be some overlap of points, just as we saw in the previous example. So we like to be able to distinguish points from each other rather than just have the alpha be 1, where you can't tell if a point is on top of a point or not. And then here, we're also going to change the size of the points to 3. Now, you might have noticed that the size argument is outside of the AAS function. And there's a reason for that. So the reason why is because the thing about it, to explain this, so when you have these arguments outside of the AAS function, what it does is that it makes it fixed, because you would only put size in here if you want the size to change based on the value of a variable. That's what the AAS function is for, where it's a place for you to put arguments where you want the argument, say, for example, the color to change based on the values of a variable. So in this case, color would belong here because you want the color of the points to change based on the sex of the professor. If you don't want it to change based on the sex professor, what you can do, you can just simply put it outside of the AES function and just change the color to whatever you like. So let's say the color, you want the color of the points to be blue, for instance. So let's say, yeah, let's say you want the color of the points to be blue, as an example. Or, okay, looks like it's not, yeah, something's up with my thing, but generally, yeah, but
I think you have to put it in the geom itself.
the geom point. Oh, yeah, thanks.
Yeah.
Okay. Right. Now you can see that the points have changed color, where they're all the same color. So generally, if you want your certain things like the color or the size to change based on a value of a variable, you put it in the AES function here. If you don't want it to change based on a value of a point, or you want to set it to some fixed value, you put it outside. So typically in the geom function that you're using, that tells the ggplot what kind of plot you want to show. Yeah. So that's just a little note that I want to make. Sure. All right. And so, all right, so going back here, so you have alpha and the size of the points are fixed. And then you have this function geom smooth, which basically creates all these regression lines that will be fitted onto these data points here. And this method just tells you what kind of regression formula you use. In this case, it's using linear, like linear regression linear models. That's what LM stands for, linear models. And then it just tells you the formula, like what kind of regression model. So in this case, it looks to be some kind of polynomial, so like quadratic equation. And then the size here just tells you how big do you want these regression lines to be. And then these are just extra labels just to change just the labels, making sure that the scales is in dollars, and then the color of the points, and then just how the plot looks. And so when you run this, so this might take a while, right? And this is what you get. So one of the benefits of grouping is that any arguments you put up here will scale down to affect the other geom functions. So you see here, you have two separate regression lines. Part of it is because in this AES function, we specified that the color is sex, which affects these other two graphs itself, where you have the points change color based on the sex of the professor. And then you also have the regression lines you have two separate regression lines based on the sex of the professor. And so that's why you see that there's two of them, because we specify in our AES function that we want the color to change based on sex, and that affects all the other geom functions as well. So that's just another thing too. If you like what argument you send AES, so mean you don't do anything else in the geom functions, it will scale down to affect all the other geom functions. Yep. All right. Any questions?
No,
All right.
looks good. But yeah, it's like from the other graph where it was like the circles and the triangles, you see in that one how few females there are. So yeah, there would have been no way to see it in like the other one. But yeah, I like this graph way better.
Definitely. And it seems kind of busy, but you can kind of tell where the points are. Yeah, definitely. Yeah. All right. So from these previous examples, you have seen how grouping is very effective in being able to plot multiple variables. But there's also another way you can plot multiple variables. And it brings up to one of the things that we brought up earlier, in that you don't want your graphs to be too busy. And one of the ways to deal with that is with faceting, which is another concept that we're introducing here, where basically the idea of faceting is that you make completely separate graphs based on the values of a variable. It's another way you can plot multiple variables, except unlike grouping, we make separate graphs based on the values of a variable, rather than lump them all on a single graph and just simply change how it looks in order to reflect the values of a variable. And the way you can do faceting is through the facet wrap function, which allows you to make multiple graphs of the same type, where each graph is basically the same as the other, except that the type of points that are on there are based on the values of another variable. So to demonstrate this, let's go through an example of a visualization. So let's go back to our studio, and let's kind of run through an example. So in ggplot function, you have this, you just set up your ggplot function, set salaries, and then in your AES, let's say we want to look at a histogram, based on just the salary on our x-axis. And this is stuff that you may remember from chapter 3, where you learned about plotting univariate data, just plotting a single variable. And your histogram, it's kind of the same way you set up, where you have your geom histogram, and then here, this argument here just changes the color of the bars, in which case it's going to be a shade of blue, cornflower blue. And then you have color being basically the color of the outlines of the bar, like the lines that are bordering the bars, which is going to be white. And so if you just run this by itself, you just get a basic histogram. So I can kind of show you right here. So if you just run this by itself, you just get your usual histogram, right? And now this is where we add facet wrapping. So the way it works is with facet wrapping, you add the facet wrap function, and then you use this squiggly line, this tilde, on your keyboard. And then you type in the name of the variable that you want to facet on. Basically, what variable do you want to separate the graphs on? So in this case, we're separating the histograms of salary based on the rank of the professor, which means we're going to have different graphs of the salary of professors, where each graph corresponds to the rank of a professor. So there'll be one histogram for an assistant professor, an extra graph for an associate professor, and then an extra graph for professors. And then this end call argument basically controls how many columns do you want. So in this case, I just put it as one, where all the graphs, separate graphs that we're plotting, are going to be in one column. And you can change it if you like, but this is just as an example. And so when we run this code, you can see here that we have different histograms of the salary data, except in this histogram up here, we're only showing histogram data for the salary based only for assistant professors. And then we do the same where we only show salary data for associate professors in this histogram. And then finally, we only show histogram data for the salary based on whether or not the professors. So you can see here, we have 3 different histograms based around salary data, but each graph corresponds to the value. It's a different type of a professor. So that's just another way you can plot multiple variables, where you can just basically break them apart based on the values of another variable. So in this case, we're breaking apart the salary data based on the rank of the professor. So that's just another thing that you can do. So and you can see here that it's not as busy as the other graphs, because we have separate graphs to look at instead of just all this information being dumped onto one graph. So that's just another option that you have when it comes to just plotting multiple variables, and that you can just facet them. Sure. All right. But that's not just the only way you can facet. There's also another function that you can use in order to facet the variables. And this function is really good, especially if you run into the situation of, what if I want to facet based on multiple variables, more than one? Because in the previous example, we only faceted based off of one variable, in this case, the rank of the professor. And this is where facet grid comes into play, where you not only can do the same thing as we did up here with just faceting just based on rank, you can also facet for more variables. And this is where it comes in. And facet grid kind of operates similarly to facet wrap, but there's some specifics on how you do it when it comes to multiple variables. So we're going to demonstrate that with an example. So let's go back to our salary data. All right, ggplot, where we have your salary, and then you have your AES, where you just want to look at salary data. And this stuff right here, if you're curious, this is just to make it so that way it's in units of tens, especially if you just want to go, instead of looking at salary itself and just its regular units, you want to look at it as in thousands of dollars. So this just changes the units of salary, but overall, it's just this very similar code to what we ran before with facet wrap. And then you have your geom histogram. And then here, this is where it gets a little different, where you have facet grid here. And the way you set it up, it's kind of similar to facet wrap, except if you're plotting multiple variables, you have to keep in mind this formula, the way it works. As for this formula here, the formula for a facet grid function is that on the left of this tilde function, this kind of squiggly line, is where is the variables that you want to be row variables. And then this on the left are the variables that you want to be column variables. So in this case, I'll show you when by running this. I think it's much easier to see. So you can see here, sex here, because it's on the left of the tilde sign, is treated as a row variable. You kind of see it by here, where we have all these histograms, right? All the histograms on this first row correspond to females, and all the histograms on the second row correspond to males. So, and that's just an example of plotting something as row variables for this facet grid. And then rank, it's being plotted as column variables. And you can kind of see it here with these histograms, where each column of histograms corresponds to each of the ranks of the professors. So you have assistant professor, associate professor, and then finally, professors themselves. So you create this nice little grid where you get different combinations of values and different histograms based on the values of say, sex and rank in this case. So this histogram is for assistant professors that are female, and then associate professors here that are female, and then vice versa. And you can kind of see how it works here. Reading these collections of histograms. So that's just a very neat way in which you can plot, say, more than multiple variables, and you want to facet based on the values of 2 variables. You can certainly do more, but then it runs into that other issue that we brought up earlier, that what if it becomes too busy? And that's another conversation, but generally this is a way in which you can facet for multiple variables. Sure. Okay. Now, so far, we've covered how you can group variables together and facet them in one graph. And like, and one thing that you might wonder is, can we facet and group variables together? Absolutely. You can group variables together and facet them together. They're not mutually exclusive. We can do both of them at the same time. And I'm going to show you an example that will demonstrate that. So as an example, let's look at the gapminder data from the gapminder package. And basically, do grouping and faceting together. Now, as a extra discussion for for the formula for facet grid. So basically, for this data set, I'm going to kind of walk you through the code a little bit, as this one is pretty busy. I mean, this stuff I pulled from the book, but I'll walk you through it. So here, the first thing that is happening here is that we're grabbing salary data and we're getting summary statistics for it, where we're getting the mean and the standard deviation and the standard error of the salary data based on the sex, the rank, and discipline separately. And that's kind of what's happening here. We're getting all these summary statistics that are separated based on sex, rank, and discipline together. And then this one just changes the labels for discipline, where instead of just A and B, it changes it to theoretical and applied. And then here's where the ggplot stuff comes into play. So we have these summary statistics in plot data. And then you have your AES, where on the x-axis is the sex of the professor. And then y is the mean. And then here we're changing the color of the points based on the sex of the professors. And then you have G on point, where we're just changing the size of the points to be size 3. And then this just adds an error bar, where you're trying to kind of get sort of like the sort of boundaries of the range of values based on one standard deviation from the mean. And then the width just kind of changes the size of these error bars. Right. And then this just changes the scale. So that way, like, it just changes those little tick marks and just the scale of it. And facet grid, this is something that we've talked about. And you may notice that here that they have a dot here to the left of the tilde. Now this dot basically means that there is no row variables in this facet. And so if you ever run into a situation where you don't want any row variables, you don't want any column variables, all you do is you just put a dot where you don't want, say, row or column variables, depending on which one you don't want. So in this case, the dot is to the left of the tilde sign, which means that we don't want any row variables. If you don't want any column variables, all you have to do is just put a dot here where rank and discipline is. And then just put those variables in the other position. And then these are just aesthetics, just changing how it looks and just the labels of it. And when you plot it, all these points in the gap from the gapminder, salaries data, you could see here how we have different sort of you can think of them as sort of like a box plot, these plot based off of the values for the rank and the kind of discipline they're at. And this is kind of where this faceted grid argument comes into play. Because we put a dot here where you would put the row variables, you can see here that there are no variables on the side. It's not like before where we had row variables here. In this case, we had the row variable be sex. So yeah, so that's why you don't see any values here, but because we put a dot there to indicate we don't want any row variables. And you can see here rank plus discipline, which means that the different values for rank and discipline are now put on the column right here. So we have different combination of values. So this plot right here goes for assistant professors and that are theoretical. And then this plot here goes for assistant professors that are applied, and then vice versa. And then you also have this x-axis where the points change and the color too, based on whether they're male or female. And so there's definitely a lot more to this, but these are just some of the examples of on which you can modify your plots in order to be able to plot multiple variables. And where you can change the color, the sort of the size, the shape of the points, the transparency even, and even just facet them if you don't want them to be all bunched up onto one graph, for sure. Let's see here. Okay. Yeah, this one's pretty cool. Yeah, this plot's cool. Right. Okay, I guess that is it for chapter 5. Just some examples of grouping and faceting for plotting multiple variables. And before I end, I want to ask if anyone had any thoughts or questions. Anything about what we learned so far? Any comments?
Not particular. I guess I never really fully realized the difference between facet wrap and facet grid. So this was like this last part was very interesting to me. Yeah, very cool. Awesome.
Yeah.
Awesome presentation, Ken. Thank you so much.
Of course, yeah. Of course. Yeah, thank you all for coming. And with that, if anyone doesn't have any extra comments or questions, I want to say thank you all for coming. That's pretty much marks the end of this presentation on chapter 5 of multivariate graphs. Thank you all for coming and hope you all found this to be very useful. So thank you all so much.
Yeah, very, very useful. Virtual round of applause for Ken for sure. Thanks. And yeah, so this was chapter 5 of data visualization with R. So next week, Femi will be reviewing chapter 6, which is maps, and just general things. We have people signed up through chapter 9. So we do have 13 chapters total if anyone wants to sign up for any of the other upcoming chapters. Also, so I'm scheduled for chapter 8, which would fall on Sunday, May 14th. That's the day after my graduation, so I won't be able to meet that day. And Ken and Katomi are graduating with me, so I'm assuming that might not be a good day for the three of us. So I'm thinking potentially skipping that week if that works for everyone else. Yeah. And yeah, but yeah, this is great, Ken. Thank you so much. And yeah, so if you're interested in Ken and doing another chapter, go ahead, sign up for it. And yeah, anyone else, yeah, sign up for the chapters. And I'm looking forward to meeting again next week as Femi reviews the chapter on maps. So yeah, thank you. And I hope you have a good rest of your weekend.
Thank you,
Thank you
Ken.
Of course. Take care, everyone.
Bye, everyone.
Bye.